Hello everyone. In the previous classes, we have studied about what is differentiation, definition, and the formula to find the derivative of some continuous functions. And also, we have find the derivative of the function which is polynomial in the form x raised to n by first principle method. In today's class, let us learn the derivative of the function sin x. So let us take y equal to sin x. To find the derivative of sin x, we use the method of first principle, right? So we know that this sin x is continuous function. So let us consider f of x equal to sin x. Then we need f of x plus h. So f of x plus h is sine of, in the place of x we have x plus h, right? So x plus h. The formula states that dy by dx is equal to limit as h tending to 0 f of x plus h minus f of x divided by h. So let us substitute all the values. Limit as h tending to 0. The value of x plus h is sine of x plus h, and the value of f of x is sine x divided by h here. So which is in the form sine a minus sine b. As you know, sine of a minus sine of b, which is equal to 2 cos a plus b by 2 into sine of a minus b by 2, right? So let us apply this here. Limit as h tending to 0. Here 2 cos a plus b. Here the value of a is x plus h, value of b is x, right? So x plus h plus b, a x plus h plus b divided by 2 into here sine of a minus b, right? Sine of a value is x plus h minus b value is x divided by h. A minus b by 2 here, whole divided by h is there. This will be equal to limit as h tending to 0, 2 cos here x plus h plus x, that is 2x plus h by 2 into sine of x plus h minus x. Here x will get cancelled, so we left with h by 2 whole divided by h, right? So as you know, the term here limit as some theta tending to 0 sine theta divided by theta, which is equal to 1. Let us combine this together. But here see that in the place of theta we have h by 2. Here only h is there. So here also we need h by 2. If you take h by 2 here, then we need to multiply 2 here, right? So now we can take sine of h by 2 by h by 2 as one term, as limit h tending to 0, right? So same term is there, limit as theta tending to 0 sine theta by theta. Here in the place of theta we have h by 2. So this is a sine of h by 2 by h by 2. As limit in the place of theta we have h by 2, right? H by 2 tending to 0. Whenever this h tending to 0, then h by 2 also tends to 0. So you can take h by 2 here also. You can apply the same thing here. So limit as h tending to 0. So the term is 2 cos 2h plus h, 2x plus h divided by 2 whole divided by 2 is there, and this term is tending to here 1, right? So into 1 will come this term. So here we can cancel 2 2, and whenever applying the limit h tending to 0 is there. So whenever you put the value of h as 0, we left with cos of 2x by 2 here, 2x by 2, h value 0. So 2 get cancels, we left with cos of x. So that is d by dx of the value of y is sin x. So d by dx of sin x is nothing but cos x. So which is very important. Derivative of sin x is cos x. So please remember, derivative of sin x is cos x. Let us solve some more problems in the next class.